see, 37. So let's jump down to 37 on the review. Oh, my bad. I have the wrong thing pulled up. Sorry, guys. Just one more second. The wrong assessment pulled up. All right. Once it decides to load, there it goes. Okay, so number 37 is the integral of, okay, so it's telling you to use trig sub, and it's saying the integral of the square root, and then mine says x squared minus 49 over x dx, and it tells you to let x equal 7 secant theta. I think maybe the 49 is not consistent from one to the other, but you know, maybe it's 64 and they're telling you to use 8 or something like that, but should be basically the same thing. So they're going ahead and telling you that. We should be able to figure that out at this point. So you know, it's 7, so the coefficients match. It's secant because it's secant squared minus 1 that we're going to end up with. And so then dx is the derivative of that, which is 7 secant theta tangent theta, and then it's d theta. And so then, okay, I'm going to do the square root on the side. So you get the square root of x squared minus 49. Well, that's the square root of 7 secant theta squared minus 49. That's 49 secant squared theta minus 49. And now we're going to factor the 49 out. And then secant squared minus 1 is tangent squared. And so then that's 7 tangent theta. So, all right, so we got 7 tangent theta on top. So the square root gets replaced with that. The x in the bottom gets replaced with secant. And the dx gets replaced with 7 secant theta tangent theta, man. Make that a little bit neater. 7 secant theta tangent theta d theta. Now, there's a lot more to do still, but are there any questions to hear? Is everybody starting to get that or getting that at this point? Man, my bad. I just noticed the, let's do this. Okay. Can you guys see all that now? Can you see everything? I don't know if you were able to see. Sorry, I wasn't paying attention. Okay. I think you can see everything now. Okay, cool. Thanks, Alyssa. All right.
Okay. Let me know.
Siri thinks I'm talking to her. Man, I am.
Sorry.
Okay. I think Siri's off now. All right. So anyway, now we're going to cancel the secants. And we could go ahead and cancel these 7s if we want. And then we're going to pull the 7 out. And we're going to be left with tangent squared theta d theta. And so now we're going to try to do that integral. Well, to do the integral of tangent squared, it's not a basic form, but we know that 1 plus tangent squared is secant squared. So we can rewrite this as secant squared minus 1. That's a good idea because secant squared is a basic form. So we can split this into 2 integrals. The integral of secant is tangent. And then the integral of 1 d theta is theta. All right, any questions to there? Okay. And so now we're gonna go back to x. And so I think one of the parts of the question is actually to draw the triangle. Let me double check. Yeah, so it says sketch and label the associated triangle. So, okay, so we're gonna draw the triangle anyway. We'll do that over here in red just to make it stand out. So we've got x equals 7 secant theta. We solve this for the trig function. So secant theta is x over 7. So we draw a triangle in the first quadrant. This is theta. So secant is the reciprocal of cosine. So it's the hypotenuse over the adjacent side, or r over x. So we put x here. and 7 here. And now the Pythagorean theorem gets us that this is the square root of x squared minus 49. So that is the triangle you want to draw, wherever they've got that on the choices. And then to go back to x, we read tangent off the diagram. Tangent is y over x, or opposite over adjacent. So it's the square root of x squared minus 49 over 7. And then when you have theta not in a trig function, then you use inverse trig to write what theta is. So if secant of theta is x over 7, we write theta as the inverse secant of x over 7. And then there's not much we can do with this except we can cancel those 7s on that first fraction. And so we get the square root of x squared minus 49 minus 7 inverse secant of x over 7 plus c, and then that's the answer. Okay, any questions on that problem on 37? Okay. So then the next one in chat, we've got 58 and then 26. So let's work on 58 next. Let me jump down to that. All right. So 58 says use the integral test to determine whether the series is convergent or divergent. And this is not one we want to normally use the integral test on, but it's telling you, okay, n equals 1 to infinity of n over n squared plus 4. Okay, so to use the integral test, there are several conditions to show. And I mean, on a Webassign question, you don't, I guess, have to show all this stuff, but you probably should. And so what you do is, if you're doing the whole problem, you say, okay, let f of x equal x over x squared plus 4. So in practice, pretty much what you do for integral tests is you let f of x equal whatever this formula is, except with x in it. And so then the function has to be continuous, positive, and decreasing, and it has to equal the formula here. So obviously f of n is equal to a sub n, where an is this. A sub n is whatever you get when you plug in, I'm sorry, f of n is whatever you get when you plug in n here. So that's the same thing. And then f is continuous, positive, and decreasing. So it's continuous on, and what we want is 1 to infinity, because that's what we're dealing with from 1 to infinity here. This is continuous everywhere. The only thing that would make something like this discontinuous is if there was 0 on the bottom, and there's no way to get 0 out of x squared plus 4. F is positive on 1 to infinity as well. So continuous, positive, and decreasing are the conditions. F is positive because x is positive and x squared plus 4 is positive when you're going from 1 to infinity. And then F is decreasing. This is the one where you actually have to show a little bit in order to prove that. So we want to prove F is decreasing on 1 to infinity. To show that, we show that the derivative is negative. So F prime, we use the quotient rule here. So it's the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. That's x squared plus 4 minus 2x squared over x squared plus 4 squared. That's negative x squared plus 4 over x squared plus 4 squared. and we'll say on 2 to infinity. So eventually it's decreasing, which is enough for this test to work. But negative x squared is going to be bigger than 4 as long as, actually, we probably should say less than or equal to 0, but it's going to be 0 when x is 2, but it's less than 0 for everything else. So then this is decreasing. It'd be better if it was 1 to infinity, but it technically doesn't matter because just the first term. And so what they want you to do is you technically should show this anytime you're using the integral test. But the main thing is then, okay, because that applies, then you do the integral from 1 to infinity of that function. And if this integral converges, then the series converges. And if this integral diverges, then the series diverges. Well, the way you do this integral is it's an improper integral. So you do the limit as r approaches infinity of the integral from 1 to r of x over x squared plus 4 dx. And so back when we were doing improper integrals, we said, okay, well, this is, you can't deal with it when this is infinity, but you could do the integral from like 1 to a billion or 1 to 100 billion or something even bigger than that. And so you want to go from 1 to a finite number, but as that finite number r approaches infinity. And so then, okay, we do this antiderivative now. And this is a quick u sub, which I'll actually do up on the top left. So if I was doing the integral of x over x squared plus 4 dx, u is x squared plus 4, du is 2x dx. So we quickly get 1/2 integral 1 over x squared plus 4 times 2x dx. So I move the x off of the fraction, multiply inside by 2 and outside by 1/2. That gets us 1/2 integral 1 over u du. That's 1/2 log of the absolute value of u, but u is x squared plus 4 plus c. So then, and I know I'm going fast, so if there's any questions on that, please don't hesitate to unmute yourself and ask, or type it in chat. I'm happy to talk to you about it there too. All right. So, okay, so because this is a finite number, this is now a proper integral. You can do the fundamental theorem of calculus, which says we can get the antiderivative and plug in the bounds on the integral. So we get 1/2 log absolute value x squared plus 4 evaluated from 1 to r. That's now the limit as r goes to infinity of 1/2 log absolute value r squared plus 4 minus 1/2 log. And if I plug 1 in there, whoops, I get 5 because it's 1 squared plus 4. And then that actually goes to infinity, because as r goes to infinity, r squared goes to infinity and plus 4 goes to infinity, and log of that goes to infinity. Half of infinity is still infinity, and then minus this is still infinity. So this diverges. So the series diverges by the integral test. And like I said, we wouldn't want to do any of that unless we were told to. So if you look back at the original problem, this is one where we probably should have known that it was going to diverge. We should know that it's going to diverge because this is going to behave the same way as n over n squared, which is 1 over n. That's the harmonic series. So if you weren't told to do the integral test here, you would do the comparison test. You do the limit comparison test here with 1 over n, and 1 over n diverges, so then so does the original with the limit comparison test. Okay, and so the way the Webassign is stated, it says evaluate the following integral, so you would put infinity for what that is. Since the integral is not finite, then the series is divergent, is what you would actually type in there. Any questions on that problem on 58? Okay, and then we've got a few more in here. We've got 26 and then 75 and part of 74. So let's go back up to 26, just try to go in order. I'll try to go in order with the way you guys are asking these. Okay, so 26. is another integral. And so we've got the integral of 5 cosine of the square root of x dx. And so, okay, this one is pretty challenging. It ends up being u substitution and parts, but it requires a good bit of work to get it to work out. So you actually start with u substitution, where we're going to let u equal the square root of x, which is x to the 1/2, and then du is 1 over 2 x to the negative 1/2 dx, and then that's 1 over 2 square root of x dx. Normally we would think that's not going to work, but we can kind of force that in. And so the way we force that in is we multiply. So we've got 5 we pull out. We've got cosine square root of x and dx. So this is exactly what was in the problem to begin with. I just spaced it out some and pulled the 5 out. I need 1 over 2 square root of x right here. So I'm going to put that in. But in order to do that, I also have to multiply by the reciprocal. So I need a 2 because this is really 1/2. I'm going to pull the 2 out. So we have 5 times 2 out here. And then I need a square root of x, and I can't pull that out, so I put square root of x inside. And so now the reason that's going to work is because this is now happens to be u cosine of u du. And it's not obvious from the beginning that it's going to work out that way, but this is now integration by parts. So it happened to work out because the u ended up here. So we're going to do integration by parts. But instead of u and dv, we're going to do v and dw. And so again, I know I'm going quick, so if there's questions, please interrupt. Please let me know. Is everybody good so far? All right. So then v is u, dw is cosine u du, dv is the derivative of u times du, so du, and w is the antiderivative of cosine u du, which is positive sine. And now the parts formula for these letters would be VW minus WDV. So we're going to have 10 times all of that. So no integral, 10 times bracket VW, so U sine U, minus WDV, so the integral sine U du. We take a step to distribute the 10. And that's really important when problems get more complicated at this stage. This one's complicated at the beginning, but not bad here. And now the integral of sine is negative cosine. So we get 10u sine u plus 10 cosine, because it's negative cosine, u plus c. And then u is the square root of x. So we get 10 square root of x sine square root of x plus 10 cosine square root of x plus c, and then that's the answer. All right, any questions on that problem, 126? And then 74, 75, 74, and apparently 73, that's fine. All of those will be next. So 73, 74, 75 are next. Any questions on this one? Okay. Let me jump down. Oh, what was the reason the square root had to be inside the integral? The question is, why do we have to have this inside the integral? So you're allowed to pull constants out, but you're not allowed to pull variables out. So you cannot pull like the square root of x out of there. The 2 could be inside or outside, but we don't need it inside. The square root of x has to be inside because you can't pull the variable out. Does that make sense? Does that make sense? Okay. Other questions so far, you guys? All right. Okay. So then let me jump down to 73 and 74, 75. Okay. So ratio test, alternating series test, and radius of convergence. Okay, so I thought maybe these build on each other. They don't really, so I'll just do them in the order that they are asked. So 75 is find the radius of convergence in the interval. So find interval and radius of convergence. And so we have the sum n equals 1 to infinity of negative 1 to the n, x to the n over the fifth root of n. And so, okay, so the way we deal with this is we do the ratio test unless we came up with the series, and the way we came up with the series was to use geometric series, and that's not what we did here. So we're given the series, so we start with the ratio test almost always. Every now and then we might use the root test, but we'd only want to do that if everything was to the n, and this n is not being raised to the n. So we don't want to use the root test here. So we're going to start with the ratio test. Guess we could use the root test here, but no reason to. So we've got limit as n goes to infinity. And then if we had a n plus 1, we've got negative 1 to the n plus 1, x to the n plus 1 over the fifth root of n plus 1. And now x to the n plus 1, not bad. So we plug in n plus 1 for all the n's. And now instead of divide by an, multiply by the reciprocal of an. So the fifth root of n over negative 1 to the n, x to the n. And now we want to simplify this. So we split up the exponentials so that they'll cancel with the smaller powers. So you take the bigger powers and break them into the smaller ones. So this we break into negative 1 to the n times whatever's left over, but we choose negative 1 to the n because that's what's down here. It's not always just n and then 1. And then same here, x to the n is what we want to match. So we make it x to the n times whatever's left over. And then you can't do much with the fifth root. So for now, we're just going to leave the fifth root of n plus 1 as it is. Okay, questions to there? Is everybody good? Okay, and so now we can cancel. We're going to cancel the negative 1 to the n's. We're going to cancel the x to the n's. And that's all we can cancel. So the next thing you do on these is you figure out, okay, what can you pull out of the limit? And what can you pull out of the absolute value? So negative 1 to the first, the absolute value, that's just 1. And so that can actually drop because it's 1 times everything. If everything else cancels, then you'd want to put a 1 there, but we can drop the 1 otherwise. So we're going to just leave the 1 as is. The x to the first, we can pull that out of the limit because x doesn't change as n goes to infinity, but it has to stay in the absolute value because x can be positive or negative. And then the fifth root of n, fifth root normally can be positive or negative, but as n goes to infinity, it's positive. So we can pull it out of the absolute value, but you cannot pull it out of the limit because n is going to infinity. And so obviously n is changing. And then on the bottom, same deal. The fifth root of n plus 1 stays in the limit, but can come out of the absolute value. Does everybody follow that? Any questions? Okay, so this limit is 1, and so we get the absolute value of x times 1, which is the absolute value of x. And we're not finished, but that's what we get out of the ratio test for any value of x. So if this was 7 to the n, this would be the absolute value of 7. If this was negative 2 to the n, this would be absolute value negative 2, which is 2. Question in chat is, okay, how is this 1? Because the biggest thing on top is the fifth root of n, and the biggest thing on bottom is fifth root of n, which is then just 1. Does that make sense? Everybody clear? So, okay, cool. Other questions to there? Okay, so now we're going to try to figure out, okay, so no matter what x is, this is what you get out of the ratio test. The ratio test says the series converges if that is less than 1. If it's bigger than 1, it for sure diverges. If it's equal to 1, then we don't know. And so if it's less than 1, what we do is we say, okay, well then x is between 1 and -1 because the absolute value has to be less than 1. So at this stage, we know the center here is 0. We're going from 1 to -1. So we've got a center of 0, and we know the interval goes between 1 and -1. So the radius of convergence is 1. We don't technically know the interval because we do know it goes from -1 to 1, but we don't know whether you include these two endpoints. So to find the interval of convergence, you test the endpoints. So we'll do that in green. So if x equals -1 and if x equals +1, we need to figure out what happens. So we go to the original series. So we've got the sum, and we're going to plug -1 in for x. So we get -1 to the n. That's already there. Instead of x to the n, we get -1 to the n over the fifth root of n. And then over here, we've got -1 to the n, 1 to the n over the fifth root of n. So then here, this is -1 to the 2n over the fifth root of n, but we can write that as n to the 1/5. And then 2n is always even. So -1 to any even power is always 1. So we can rewrite this as 1 over n to the 1/5. Well, this diverges because it's a p series where p is 1/5, which is less than 1. That means that you put a parenthesis there. Okay, and so then 1 to the n is just 1 over here. So we simplify this and we get -1 to the n over n to the 1/5. This one converges. It's one where if you take the absolute value diverges, but then you go back and the alternating series test shows you this one converges conditionally. And so we would put a bracket on 1, meaning this is the interval of convergence. And so the interval of convergence is -1, 1, where a parenthesis is on 1 or -1, and a bracket is on +1. Questions on that? You guys following that? Okay, and then somebody asked about the end of 74. My bad, we did not cover talking about estimates of sums with an error less than that. Don't worry about that. Man, if you want to just guess, or I can just throw that question out, I'm happy to just give you guys the points for that question. Make sure you can do the first two parts, but the thing where it's talking about the error, I don't want to spend time going over that. That's not something we cover as part of this class. The book talks about it. It's actually not that hard. It's just I don't want to mess with it right now. So I honestly didn't notice that part of the question was there. I saw the first part and just didn't see it. So don't worry about the error part. I assume that's what you're talking about as far as the end of 74. Is that right, Jordan?
Yeah, that's right. Well, because I saw that and I could do it in MATLAB, but I didn't think it was worth the one.
If you want to do it in MATLAB, go for it. I will get, if you guys miss an 80 because you missed this number 74, or maybe I'll just make the cutoff 78%. How's that? 79%, whatever that ends up being. Because I just missed that was even part of this question. Sorry about that. We just didn't cover it. The rest of it, though, should make sense, right? Is the rest of it okay?
Yeah, it was just the error.
That's my bad. My bad. I just didn't notice it. This is the first time I've seen that was even there. Okay, so then let's go back to 73, which somebody was asking about. Yeah, it turns out it's really not that hard. It's just not something we have covered. And 3 days before the final, I don't want to do something brand new. Okay, so number 3 says use the ratio test on this one. You should be able to tell, though, that this is ratio test because of the exponential and the factorial. So if it didn't tell you to use the ratio test, we should probably know to use the ratio test. And so, okay, so AN is just the whole thing. And now we're going to find the limit of, so if you look at the question saying identify AN, well, AN would be that whole thing in here. And then it says evaluate the limit, which is what we do is the ratio test anyway. So we're going to do the limit as n goes to infinity of the absolute value of AN plus 1 over AN and so then that's the limit as n goes to infinity of -5 to the n plus 1. And then it's 2n plus 3 factorial. And just to kind of recap, the reason that is because we're plugging in n plus 1 for n. So it's 2 times the quantity n plus 1 factorial. So it's like that part is becoming that. And so then that's 2n plus 2 plus 1 factorial, which is 2n plus 3 factorial. So that's where I'm getting that. And then divided by AN means 2n plus 1 factorial over -5 to the n. So now to simplify this, we break up the bigger exponentials, or the ones with the bigger powers, and a bigger factorial into the smaller ones. So we're going to make this -5 to the n times -5 to the first over 2n plus 3, 2n plus 2, whoops. And then 2n plus 1 factorial. So you remember you take the bigger one and then you keep going down by 1 until you get to the smaller one. So subtract 1 from that, you get 2n plus 2, subtract 1 again, you get 2n plus 1. Stop there because you want to cancel with this 2n plus 1 factorial. So now we've got 2n plus 1 factorial on the top and -5 to the n on the bottom. And now we're going to cancel the -5 to the n's. We're going to cancel the 2n plus 1 factorials. And now there's nothing to pull out, although I guess you can pull out the 5 if you want, but the absolute value -5 is 5. And then the bottom is 2n plus 3, 2n plus 2. And now the limit as n goes to infinity of this is 5 over infinity, which is 0. And so this isn't an interval of convergence. It's just, does this converge or diverge? This is less than 1. And because that's less than 1, then the series converges absolutely by the ratio test. And then Webassign has some stuff for you to fill in about that. So like it says, again, it says what's AN, and so you fill that in, and then what is the limit? Well, the limit's 0. And then since it's less than 1, then okay, it converges. I think it's just saying convergent. Yeah, the series is convergent.
So what do we put in for the identify A of n then?
AN should just be the whole thing. So it should be like -5 to like this.
Oh, okay. Just retype that pretty much.
Yeah, it should be that. Yeah, type that. If it's not counting that, let me know and I'll find out what it actually wants. This is what I would call AN. If this came, it's possible this came from a different textbook where they're doing maybe AN's the absolute value of it, but go with this. And if that doesn't work, then it's maybe 5 to the n over 2n plus 1 factorial, but I would say it's the whole thing. Okay. All right. Any questions on that? Any other questions on that? All right. Okay. Okay, the next ones were 79 and 84. So let's jump down to 79. Okay. So 79 is find a power series representation for f of x equals 1 over 7 plus x, and then it asks for the interval of convergence. And it says to center it at 0. And then, okay, so this one's one that's almost in the form a over 1 minus r. So you want to factor the 7 out to get it so that this is a 1. And now we want to move the 7 up here, make this 1 over 7, and we want to make this minus. So we're going to make it 1/7. And then instead of 1 plus x over 7, we're going to make it 1 minus negative x over 7. Same thing. But now a is 1 over 7, and r is negative x over 7. So then the series is the sum k equals 0 to infinity of 1 over 7, so a r to the k, so negative x over 7 to the k. And then you can simplify that, and you can simplify that to the sum k equals 0 to infinity of negative 1 to the k, and then over 7 to the k plus 1, x to the k. And we're getting that by doing, okay, the negative is treated as negative 1 times x, so negative 1 to the k. The x to the k we put at the end, or you can put it in the top. And then you've got 7 to the k, but you've got 7 to the k times 7 to the first, so that simplifies to 7 to the k plus 1. I guess they're using the letter n, so use the letter n instead, but that's the series that you put. And then for the interval of convergence, we don't need the ratio test when we're using a over 1 minus r. You just say, okay, well, the absolute value of r is less than 1. That means we get the absolute value of negative x over 7 is less than 1. If absolute value of something is less than 1, that means it's between negative 1 and 1. And now we want to get the x by itself, so we're going to multiply by negative 7. And so that gets us positive 7 is bigger than x is bigger than negative 7, which means the interval of convergence is negative 7 to 7. And you do not include the endpoints. You don't need to test them for the geometric ones. And they're definitely not included. If you did test them, they would both diverge. All right, any questions on that? And then we're going to move to 84 and then 55 is what I'm seeing in chat. Okay, so 84 says use a Maclaurin series in this table to obtain the Maclaurin series for the function. And so the one I'm getting on 84 is f of x equals x cosine of 3x. And then if you click the link for the table, it pulls up. And if you look at cosine, it's giving it to you in terms of n. It gives you cosine x is the sum n equals 0 to infinity of negative 1 to the n x to the 2n over 2n factorial. I'd probably write that a little differently, but that will work. So negative 1 to the n, x to the 2n over 2n factorial. So, all right, so the way this works is that if cosine x is equal to this with x here, cosine 3x is equal to this with 3x here. So then you've got x times the sum n equals 0 to infinity of negative 1 to the n, but instead of x to the 2n, it's 3x to the 2n over 2n factorial. Now there are two more things we can do, but first to get cosine 3x, we just replace x with 3x. Does that make sense to everybody? Okay, now we're going to simplify this and make it 3 to the 2n and then x to the 2n. So we're going to leave the x out here for now. And then probably what I'd do is make it negative 1 to the n times 3 to the 2n over 2n factorial, and then I usually put the x at the end. You don't have to do that, but that will work. So you get 3 to the 2n and x to the 2n, and just kind of rearrange stuff. And now the x needs to go in here. So this is x to the first. When you multiply it by all this, it'll get combined with the x to the 2n, and you add powers. So you get x to the 2n plus 1 because the x outside is x to the first. And then that's the answer. Does that make sense to everybody? Any questions on that? Okay. And so the next, oh, my bad. Question in chat is there a difference between a Maclaurin series and a Taylor series? Not really. A Taylor series can have any center. A Maclaurin series must have a center of 0. So all Maclaurin series are also Taylor series, but not vice versa. Does that make sense? Okay. And they're all considered power series. Okay, so all of these are power series. None of that really changes the direction or changes what you do. None of that terminology changes what you do, except when you say Maclaurin, the center has to be 0. All right, any other questions so far? Okay, so the next one I think is 55. Let's go back up to that one. Okay, so we're going to determine whether this is convergent or divergent, and if it's convergent, find its sum. If it diverges, then say it diverges. And so the one I'm getting, and this may be different on yours, is 1/5 plus 1/10 plus 1 over 15 plus 1 over 20 plus 1 over 25. Is this close enough to what you have, Jordan? You were the one that asked this.
Yeah, it is.
Okay. All right. So you want to try to come up with a formula for this. And it actually, at first, kind of looks like it's geometric. But if it were geometric, you'd be multiplying by the same thing every time. So to go from 1/5 to 1/10, you multiply by 1/2 because you multiply the bottom by 2. So you multiply by 1/2. If you multiply by 1/2 again, you get 1 over 20, which is not 1 over 15. So we need to come up with a different way to represent this. Well, the bottom keeps increasing by 5. And so one way to write it, man, there's a couple ways to write it, but if you notice that it's the same thing as this, I don't know if you notice that or not, but it's multiples of 5. It's like 5, 10, 15, 20, 25. Does everybody see that? And so either way, you can write it as the sum k equals 1 to infinity of 1 over 5n. So somehow we need to notice that the bottom is 5n or 5k. We'll just make it n. My bad. So n equals 1 to infinity. So it's 1 over 5n there. Does that make sense to everybody? How I'm getting that? Either noticing this or just noticing it's 5, 10, 15, 20. Somehow get to here. And then from here, we factor the 1/5 out. And this is a constant multiple of the harmonic series. Man. And so then this diverges because it's a constant multiple of the harmonic series. Does that make sense? Okay. Let me see if there's one around this that's similar. Yeah, I don't see one, but okay. Other questions? 57, okay. All right. So, okay, so use the integral test to determine whether this series is convergent or divergent. So on this one, I'm going to skip the conditions because it's just asking us to use the integral test. It doesn't say to show the conditions. So we've got the sum n equals 1 to infinity, n to the 5th, e to the negative, n to the 6th. So you should say, okay, and again, this one's telling you to use integral test. That's probably not the best way to do it, but maybe here we would want to. So let f of x equal x to the 5th e to the negative x to the 6th. And so, okay, f is continuous positive decreasing. You should show that, but they just want us to go ahead and do the integral test. So we're going to go integral from 1 to infinity of x to the 5th e to the negative x to the 6th. So because it's going from 1 to infinity, then we're going to go limit as r goes to infinity of the integral from 1 to r. That lets us do an antiderivative. This is a quick u substitution where u is negative x to the 6th, du is negative 6x to the 5 dx. We need a negative 6 inside, so we multiply by negative 6 inside and 1 over negative 6 outside. All right, so skipping a little bit up here, we get negative 1/6 e to the negative x to the 6 plus c. So we come back down to this problem. And now we plug in r, plug in 1, and subtract. And so now as r goes to infinity, r to the 6th goes to infinity as well. Negative infinity is negative infinity, and then e to the negative infinity goes to 0. So this part goes to 0, and then we get minus negative, so plus 1 over 6e, which is 1 over 6e. Oh, my bad. And so that's, when it says evaluate the integral, that's what you get, since the integral is finite. So because it converges, the series converges by the integral test. Does that make sense? Everybody good? Okay, the question in chat is, why doesn't the even power of 6 make r positive? Because the negative is outside of it. So it's like the difference between this. Like if I have negative 3 to the 4th is 81 versus negative 3 to the 4th is negative 81. Same deal there, that that negative is not being raised to the 6th power. So it's negative infinity. Does that make sense? Okay. Other questions? Now, if it was this, that would go to infinity. Does that make, you see what I'm saying? All right, so that's the difference there. Other questions on this one? Other questions in general? We might do maybe 1 or 2 more if you guys have them. Okay. Okay, so if there's no more today, go take a break, study some today, tomorrow, but definitely study Sunday and Monday. Monday, you can take the Webassign part of the final anytime during the day. It'll time you for 1 hour when you start. It's designed to take like 30 or 40 minutes, so you should have plenty of time for the Webassign. The Webassign portion is 10 questions. They're not 5 points each, but it is 50 points. there's one volume question that's worth, I think, 9 points, and then the rest of them are worth either 4 or 5 points on the Webassign part. And then the written part will be worth up to 55 points. There's 5 bonus points built in. So if you got every point on the final exam, you'd have 105%. But you can get 100 points and get 100% of the final, or 90 would be an A. So that's how the final set up. The written part for me is not done yet. Other instructors are working on theirs. I'll definitely look at them, make sure they're fair. Ivana and I both do that to make sure that all the tests are fair. Alyssa's asking main thing to study on the final. I mean, it does cover everything. So the biggest topics in the course, I think there's 5 major areas in the course. So the 5 major areas are integrals, applications, but specifically, whoops, there's an L with integrals usually. Applications, so specifically area and volume are the most important ones we covered. So integrals, area, volume, and then series, and then power series, and parametric and polar are the 5 big areas. Now that's, like I said, big areas, especially the first 4. So I'd make sure you're studying those. I do think this bonus is really helpful. I think it covers a lot of stuff, but also you might want to go back and look at like the old exam packets that are in the shared drive. So if you go in the shared drive under the old exams, there's several semesters of old exams 1 through 4 in most cases with solutions. So use that to study. Maybe look at the parametric and polar worksheet separately, because a lot of times those aren't on the exams. There are semesters where parametric does make it onto the exam 4. I can't remember a semester where polar is on exam 4. It's almost always done after the 4th exam. For us, the bonus assignment that you're doing on Webassign is really good, but it does not include parametric and polar. So you definitely want to look at the worksheets on those. But yeah, it just kind of depends on what you guys need to practice for the final exam. I would definitely go back and look at old exams, but then focus on stuff that actually by Sunday, I'd be focusing on stuff that you're actually good at. So like today, tomorrow, you still have a little bit of time. If there's something you really didn't learn well, go back and relearn that. But then by Sunday, especially Sunday evening, and then Monday, if you're studying before you take the written part, study stuff that you're good at. Like make sure you can do volume. You want to get right the stuff you're actually really good at. If you aren't great at improper integrals, it'd be good to be able to go learn them now, but you don't want to learn that type of thing last minute. I think what a lot of people do is study the really hard stuff last minute. And if you do that, then sometimes you miss the hard stuff, but you also miss something that you were good at to begin with. So like make sure you're able to do the stuff that you are good at. Don't expect 20 of the hardest problems from the semester. Not to say the final's easy, it's not, but it's not meant to pick out the hardest things either. So it's meant to make sure that you can do the main things in the course. Does that make sense? Does that help at all? I don't know if I was just rambling, but I think trying to be helpful. All right, good. All right, other questions, you guys, before we get out of here? Okay. All right, so we will do a review session on Sunday from 3 to 5. Colin, let's see what 17 is, see if it's quick. If it is, we will. If not, we will shove that till Sunday. I will try to get 17 now. Yeah, okay, we can do 17 pretty fast. All right, not that it's easy, it's just easy once you notice what to do. So on 17, we've got the integral of cosine x over sine to the 4th x dx. And even though it's a fraction, you've got an even or an odd power of cosine up here. So what you want to do is let u equal sine, and let du then is cosine. So without really doing much, you've got 1 over u to the 4th du. Does that make sense? And so then 1 over u to the 4th is u to the negative 4. And then we use the power rule. So 1 over negative 3 u to the negative 3 plus c. That's 1 over negative 3 sine x to the negative 3 plus c. And then probably you would write that as 1 over 3 sine to the 3rd x plus c, and that's it. Okay, cool. Like I said, not an easy problem because it's hard to know to do that. But once you get started, it's really pretty straightforward. You just knowing how to do it. And my bad, I missed a question in the chat about a parametric equation problem when launching a projectile. I'm happy to do that problem, but I do want to wait until Sunday on that because of time. So if you want to ask that on Sunday, Andrew, remind me, or anyone else who wants to go over that, remind me on Sunday, and we will for sure do it. Just I probably won't remember Sunday that you asked that now, but if you ask it in chat on Sunday, I can do that during that review session. Okay. All right, you guys. Thanks for coming to this. Have a good weekend. Good luck on the final. Hopefully I'll see you Sunday, but if I don't see you, have a really good break. Thanks, you guys. Thanks for coming. Appreciate it.